construction, we don't define this necking as the failure, right? So this fracture is not defined as tension failure. Just like concrete, we have compressive failure. So how do we define compressive failure? When the piece of concrete crushes, that's defined as compressive failure. But in steel, it's a little bit different. We don't define this point as tensile failure, not this point. What about necking? We don't define this point as tension failure. We define this unit. That means when the steel reinforcement reaches this region, we define it as failure. Tensile. Or in other words, that is the maximum force that your steel reinforcement can carry. That's the maximum. And we forget about this region. Okay, so we don't want to see your reinforcement going into this region. If the reinforcement force is going into this region, that's close to the collapse of your structure. Okay, and we don't want to see that. So that's why we define this one as the maximum load that your reinforcement can take. We don't define this point. We don't define this point. We define this one as the maximum. Because we don't want to see your reinforcement coming close to this region. That would be too dangerous for your real structure. Okay, so those are just some basic things about the two materials in RC structures. Probably you should have seen some of these before. Right, so what's next? So what you have seen just now is tension and compression. Right, but in a real reinforced concrete structure, most of the elements are not in just tension or just compression. In your slab, in your piles, in your columns, in your beams, they don't just under pure tension or pure compression. Most of them are under bending. Right? So what actually is bending? The most simple example is, let's skip this slide first. I'll come back to this in a minute. That should be simple enough to demonstrate what exactly is bending. So you can imagine you have a beam like that, and you got two supports, no matter they are columns, walls, whatever. You support here and there, two supports. And you got 2 point loads, concentrated loads, at those two ends. Right, so it's almost common sense. If you have a beam like this, and support here and there, and you put load, so that thing will bend. Right? So we said this beam is now under bending. So if I want to draw this thing, this is a beam. Obviously, you can see the shape of the beam changes. 變咗形. So the beam actually deform. Deform is the word. 變形. Another word, exactly the same meaning, is deflect. Alright, so the beam deflect like this. You can say it deflects sort of upwards or deform like this. 向上咬彎咗. Okay, and And there is a technical term to describe that thing. So let me just draw it. I just redraw the thing here. So to make it clear, I have a beam with two supports here and there. Now I'm just redrawing this thing here, right? And I got two supports. And where are the loads? So I got one concentrated load here, and another concentrated load there. Originally, of course, it's straight. But once you put the load, it bends, and it bends like this. And bear in mind, of course, these 2 points, the beam always is in contact with the supports. So if I want to draw this deflected shape or deformed shape, so I can redraw this thing here, originally straight. Once it bends like this. Of course, it's not a straight line, obviously. So it's a curve. But when I draw the curve, I need to make sure that it passes through this point and that point, because they are always in contact with the beam. So I will draw it like, to accentuate a bit. Right? Like that. That is the deflected shape. And it deflects or it bends upward. There's a technical term to describe when it bends upwards. It's called hawking. H-O-G-G-I-N-G, hawking, to describe when the beam bends upwards like that. So it's when it bends like that. When the beam bends like this. Right? And that's called hawking. And what about if you imagine these two like a silo with it. 如果呢兩條細路行咗中間， then what happened to the beam? How does it deflect? 呢兩條靚唔係呢兩個細路，如果行咗中間會點樣 Can you sketch the deflected shape again? If these two loads move to the center, then how does this beam deflect or bend? So it would be something you can expect if you got two supports and you try to push it downward like this, right? So that's what's going to happen. Right? Can you see that? The two supports and the two kits at the center. So the beam would bend like this. And if you pay attention to how this beam bends, in this center part, it's a curve. But if you look more closely, this part, beyond my left and right finger, these two parts, they are straight. You see this part? It's still straight. Right? Same to the other side. So what that means is if you push downward here, 即係撳中間落去兩邊嘅撐咗上嚟嘅。That's almost common sense, right? But when you pay more attention to how it deflects, so this part here is like straight line, but in between is a curve, and then here and a straight line again. And of course, your dotted line must pass through these 2 points. They are always in contact with the beam. So I would draw something like that. Right? So that's also the deflected shape. So when these 2 kids move to the center, so it goes down. So the thing bends downward, and the 2 wings goes up. Right? And those 2 parts are actually straight. The center part is a curve. That part is straight. So that part is straight. But the center part is curved. And then when the beam bends downward like this, right? When the beam bends downward like this is called sagging. S-A-G-G-I-N-G. Right, so these are the terms that we are going to use today and also in the remaining weeks. So when a beam bends, it can bend like Hawking. It can bend like sagging. This is sagging. Sagging describes this part. What about this part and that part? They are straight. Straight. Straight, what does straight mean? Bend by its definition, 咬彎咗，彎曲咗。So that means these 2 parts, there is no bending. 直㗎嘛，直咪即係冇曲咯。Alright, so these 2 parts, there's no bending. Only the stack part bends. So sagging is describing this part, which is the curved part. And for the original, the left look at this, the whole thing is Hawking. Right? The whole thing is curved. Okay? Right, so make sure that you can recognize at least, first of all, these terms. What do we mean by bending? Bending, it's 彎曲。曲，首先要記住係彎咗。If it is not 曲 not bent, that means no bending. Right? And these are the deflected shape or deformed shapes. The term Hawking and sagging refers to curved part. Right? Right, and then here is just some simple illustration of what we mean by sagging and Hawking. And then we introduce the term bending moment. This is the main concept today. So what do we mean by bending moment? Right, we'll go back to this slide here. So remember what we said at the start. We said when something gets longer, 最初話咩話? If you see something elongates, that is probably that is because of tension. Tension causes elongation, and elongation is due to tension. Same thing. If the material shortens in a certain direction, that is due to compressive force. compression causes shortening, and shortening is due to compression. Then the next question is, what about if something bends? So this is the third thing that we introduced today. So elongation corresponds to tension. Right? That's what we start. When something elongates, that's due to tension. When a piece of material shortens, it's due to compressive force, compression. Then the next question, the next one on the list is, what about if it bends? 咁彎曲咗呢? What causes bending? And bending is due to what? So to fill in the blanks now, it's bending. It's due to not a force. It's due to a movement. Remember movement, that's something we talked about in week 9. So bending is not due to a force, it's due to a movement, and that movement is called bending moment. The unit for force, tension, is kilonewton or newton. Compression, same thing, kilonewton. What about the unit for moment? If you still remember what we said back in week 9, moment is not a force. Moment is force times distance. So the unit for moment is Newton times meter. So the moment is Newton meter or kilonewton meter. Right? So bending is due to not a force, it's due to a moment. This moment we call it bending moment. So bending is due to bending moment, and bending moment causes bending. Exactly the same logic here. So what exactly is the bending moment? Tension, easy, right? We know what is tension. It's simple enough to understand. Compression, it's same thing as tension except in the opposite direction. But then what is bending moment? That's something much more, a bit more difficult than tension and compression. That's what we try to discuss. Now, in the next 2 slides, these are not, these are actually computer screen capture. It's capture from an animation. So to describe bending is not something easy to describe in pure words or just drawing. So we'll try to show you a computer animation. So this is just a screen capture. Of course, the animation is on YouTube. I will show you in a minute. Right. So the most important figures is the next 2. So we will come to this. So what we try to illustrate is when you have a beam like this. Right. Imagine this is a beam. The cross section is rectangular. Right. That's the cross section. That's my beam. And you try to bend it. So we want to see what happened to my beam. Right? So I guess we'll take a short break first, and then we'll come back to look at the animation. Okay?